But I bet you guys already know some things about slope. Can anybody tell me something about slope? So it's constant, it's consistent. Yes, I agree with you. So if you're finding the slope of something, it's going to be consistent. And the reason why is because we find the slope of lines, and aren't lines the same throughout the line? Yeah. What's interesting is, have you guys heard of calculus? Okay, so calculus, if you have a weird graph, you can use calculus to find the slope at a point. Is the slope going to be the same throughout this? No, but you can find the slope at exactly that point using calculus. It's pretty cool, and it's actually not that hard. The basics of calculus aren't that difficult, but yeah, what's cool is you can find the instantaneous slope right there, and then you could also find it right there. Now what's interesting is if you're finding the slope right here, are you going up or are you going down? From left to right. If you're riding the roller coaster, are you going up or down right here? You're going up, aren't you? It's positive slope. And then on this part of the roller coaster, where are you going? You're going down. So yeah, so slope is, what we're going to be doing for slope is it's consistent. It's going to be the same slope everywhere on the graph. So maybe I should erase this picture because we're not going to be doing those kind of pictures. But it's consistent. What else do we know about slope? Anything else? Have you guys studied slope at all?
Yeah.
Last year, maybe a little bit. All right, well let's jump in then. Let's just jump in and talk about it. So notice our objectives. We're going to find the slope of a line from a graph. We're going to find the slope of a line using the slope formula. Now, here's the thing. The slope formula is not y equals mx plus b. That's slope-intercept form. That's different. But the slope formula is where you can find the slope from coordinates. From coordinates. And we'll maybe get to that today. And then we're also going to find the slope from a table, and that's actually going to be doing the same thing. We're going to get coordinates from a table, and then we'll be able to use the slope formula. Okay, so it turns out that they've got like a definition of slope right here, but I want you to write this down. Slope is a measure of steepness. Oops. It's a measure of steepness. It says how steep something is. And the reason I want to mention that is because, like, we talk about slopes of lines in here, but you can also, like, on rooftops, if the slope is too big, you can't use, if the slope is too small, if it's not very steep, you can't use shingles on it. You've got to use some other kind of roof covering. Shingles have to have a certain slope or else water will pool underneath them. But so there's lots of applications for slope where it's basically just measuring steepness. It's how steep something is. But how do you get there? Well, slope of a non-vertical line is the ratio, that just means fraction, of the vertical change, the rise, to the horizontal change, the run, between any 2 points on the line. And it says the slope of a line is represented by the letter M. Does all that sound familiar? Is that familiar, that sentence there? Maybe? So what you often see people write is they say M equals rise over run. And that's a good way to think of slope. Rise over run. And then to go into a little more detail, rise is going to be vertical change, up and down, right? And run is horizontal change. Horizontal change. And horizontal change is like left and right. You with me on that? Okay, so we've got some pictures of some different types of slope. And I like these little pictures. I can't take credit for them. I did not make them, but somebody had some fun on the computer and they made some stick figures. So this person appears to be a little unhappy. Can you guys tell that they're frowning, it looks like? Well, I think they're unhappy because they're going up the hill, right? They're going up the hill. So it could be that they are going up 5 feet and over 4 feet. That's a pretty big slope. That's pretty steep. It's pretty steep. And our slope, if we think of it as rise over run, the slope would be what? 5 over 4. 5 over 4. We like slope to be a fraction. You don't want to reduce, you don't want to make it a decimal. Just leave it as a fraction. And notice for positive slope, it's positive from left to right. From left to right, you're going up. You're going uphill. So that's positive slope, going uphill from left to right. Well, negative slope, and I'm not sure if this person's happy or sad. It doesn't exactly look human. But this thing is going downhill if they're going from left to right, aren't they? They're going from left to right. So you could think of it as going down 3. So since it's down 3, it's negative 3 over 4. So the slope would be down 3 and over 4. What do you guys think about the difference between positive and negative slope? You good? We good? Well, positive and negative are not the only options. You could also have zero slope. Zero slope. Now, why is this zero slope? Is this steep at all? Not steep at all, is it? In fact, there's zero steepness to this. So it could be that this person is walking, they went for a walk, let's say they walked 5 miles. They walked 5 miles on a flat terrain, right? They're in the desert somewhere, yeah. And they've got 5 miles that they walked. And also they didn't want to go uphill because their wig would have fallen off, you know, too steep. So they stay on this flat terrain. What's their rise? How far up did they go? 0. They ran 5. They went 5. Well, what's 0 divided by 5? 0. So is everybody cool with 0 slope being perfectly flat? Yeah. Now suddenly, I think between these examples, well actually there's a bit of a progression, I think. They're kind of going through art school. They tried to get a little abstract. They're getting better with their techniques. And then finally, wow, they graduated from art school. Look at that picture there. That's pretty impressive. Okay, now, taking a look at that skier, are they actually really skiing at this point?
No.
What are they doing?
Falling.
They're essentially falling, aren't they? Because this is perfectly vertical. Perfectly vertical. So it could be that they fall. How far do you want to make this person fall?
80 meters.
Well, okay, so 80 meters. So we'll say that each block is 10 meters. So yeah, so they're gonna, they're falling -8, 80 meters. But are they running? Are they going left or right any?
No.
They're not. So what happens is our slope is gonna be -8 over 0. But what does that say in a calculator when you punch that in? -8 divided by 0. What does your calculator say? It does not say 0.
Divide by 0, error.
It says error. Yeah, and yours was very descriptive. Yeah, it said divided by 0, error. Mine's just going to say, oh, can you guys see that?
Mhm.
No, you can't. No, you can't. Okay, all right. So 8 negative divided by 0. It says error. Why? Why does it say error? Because of what your calculator said. Are you allowed to divide something into 0 parts? No, that don't make sense. Does it make sense to divide something into 0 parts? That's like science fiction, right? You can't do that. Can't do that. So that's error. And another name for error is it's undefined. So when you divide by 0, you're going to say the slope is undefined. Now here's the thing, everybody. We got to use that terminology. You can't say error. You can't say the slope is error because people don't recognize that. What they do recognize is that undefined slope is perfectly what? Perfectly vertical. Perfectly vertical. Help is right. Help is right. Let's see. How do we get out of here? 50?
Mhm.
Yeah, I think we got enough time. I want to see if you guys can do this. Will you raise your hand when you get A and B? Nice. Yeah, when you get A and B, raise your hand. Oh, I need to let you know. Slope has to be simplified. You have to simplify slope. Is everybody with me on that? So if you need to fix something, go ahead and fix something. Slope needs to be simplified. But yeah, raise your hand when you've got the slope